All right, Ninja Nerds, in this video we're going to talk about the development of the gastrointestinal tract as well as some of the peritoneal coverings and cavity. So we have a decent outline. We got a lot to talk about in this video. So the first thing that I want to talk about before we even get into this actual GI tract stuff is I want to talk about the embryonic folding. Okay, this is really important because this is going to tell us the development of the gastrointestinal tract. So we'll start off here with the embryonic folding and talk about the development of the gut tube, the development of the peritoneum. Then after that, we'll talk about the development of the foregut, its components, vascular supply, and mesenteries. The midgut, its components, vascular supply, and mesenteries. Hindgut, its components, vascular supply, and mesenteries. Then this is going to be really important. We're going to take a little bit of time talking about intraperitoneal organs versus retroperitoneal organs. And then another thing is we're going to determine the difference between primary retroperitoneal versus secondary retroperitoneal. And then we'll finish off with some cool pathologies like omphalocele, gastroschisis, and then Meckel's diverticulum. So let's go ahead and get started first off on embryonic folding. So the first thing we have to talk about is we have to start right around the third week of development. So around the third week of development, we have this structure called a tri-laminar disc. Okay? We're not going to go into tons of detail in this video on the embryology aspect. We're going to keep it kind of simplistic here, okay? But the trilaminar disc is made up of 3 layers. The first one is this blue layer is going to be called the ectoderm, okay? Underneath the ectoderm, we're going to assume that you've already developed what's called a neural tube, which helps to develop the spinal cord, and another structure here called the notochord, okay, which will become the nucleus pulposus within the intervertebral discs. Then on the side of it, you're going to have what's called your intraembryonic mesoderm. And your intraembryonic mesoderm actually has 3 parts. Okay? One is you're going to have what's called your paraxial mesoderm, then your intermediate mesoderm, and then your lateral plate mesoderms. For right now, just remember the paraxial mesoderm helps to form what's called your dermatome, your sclerotome, your myotome. And then the intermediate mesoderm helps to form like the kidneys and the gonads. But the lateral plate mesoderm, which is made up of 2 parts that we're going to talk about, the splanchnic mesoderm and the somatic mesoderm. These are very, very important for the development of the peritoneal membranes. All right? So we're going to have that on both sides over here. So over here we'll have paraxial mesoderm, intermediate mesoderm, and then we'll have the splanchnic, which is going down here around the actual yolk sac or the endoderm, and then we'll have the one coming up here, which is actually going to be the somatic. Underneath that, we're going to have the endoderm, okay? Now the endoderm is important because the endoderm is going to be helpful for making the epithelial lining of our gastrointestinal organs, some of the accessory organs, and even some of the glands, okay? So this is what we have here. Now underneath the endoderm, underneath it, you're going to have this thing called the yolk sac. The yolk sac is important because it helps to begin with the synthesis of red blood cells. So it's very important for the production of red blood cells. All right, above that, you're going to have what's called the amniotic cavity. Now, last thing, the yolk sac secretes a type of connective tissue, which is called the extraembryonic mesoderm. Now this extraembryonic mesoderm is going to surround the actual yolk sac. So it's going to surround the yolk sac, and it's going to come over here, and it's going to surround the amniotic cavity. Okay? Now what's really cool is, you see this part here that we said we have the 2 parts of the lateral plate mesoderm? We have the somatic and the splanchnic. They develop a little cavity right here. It's called the intraembryonic coelom. And what happens is it allows for these guys to become continuous with this extraembryonic mesoderm. Okay? So they become continuous with this extraembryonic mesoderm. So again, we can call this the splanchnic mesoderm. We also call it the splanchnopluric. And then we have this one up here, which is called the somatic mesoderm or the somatopluric. Okay? And then just for the heck of it, this last part here is you'll have what's called your chorionic cavity. And there's going to be here, around it, is this outer layer of the extraembryonic mesoderm. So this is the outer layer of the extraembryonic mesoderm. And the last part here is you have your connecting stalk. all right, with your allantois, which will help to make the umbilical cord. So that's the beginning part. That's the 3rd week. Now, what happens is when we have this development of the gut tube, this embryo is going to undergo a folding process. It's going to fold in 2 planes. One is going to be a transverse plane, and the other one is going to be a sagittal plane. And it's important to understand the difference between the two. So let's go ahead and show that. All right, so here we go. We're going to have over here, we're going to take this bad boy here. We're going to have this one going into the, specifically into the horizontal plane. Transverse plane, and we'll have this one over here, specifically going into the sagittal plane. All right, so now what happens is if we draw it in the sagittal plane, this is going to help to form what's called cranial and caudal ends. Okay, so watch what happens. It's going to undergo this folding process. When it undergoes this folding process, something really cool happens here. We're going to get this little pocket right here, and then we're going to have this part right here. Okay, so this is going to be important. When we're developing the gut tube, all right, we're going to have 2 ends here. This is the endoderm. All right, so the endodermal lining is going to undergo this expansion where it's going to expand outwards and it's going to start folding. When it does that, we're going to say that this end right here, let's just say for the heck of it, this is the cranial end and this is the caudal end right here. The cranial end is going to help to develop what's called the foregut, which is going to be important. We'll talk about all the organs in that. The caudal end is going to help to form what's called the hindgut, and we'll talk about the organs of that. In the middle right here, you're going to have the midgut, okay? Now, let's talk about some of the stuff around this because it's going to be important here real quick, all right? So again, what we have around it, we might have a little bit of mesoderm around it, all right? So here we'll have some mesoderm. An important thing, again, remember, is that you're going to have a lot of stuff happening here that we're not showing. We're just trying to focus primarily on the gut tube and the derivatives of this endoderm and some of the mesoderm, okay? So you're gonna have some mesoderm here that is gonna be surrounding it. Some of the mesoderm towards the cranial end will help to form what's called the pericardial cavity and the heart, and you'll also have some other structures there developing too. Now around that, what should we have? We should have the ectoderm. So now we're gonna have around that the ectoderm. The ectoderm is important because it helps to form the skin. It also helps to form the central nervous system, which is the brain and the spinal cord. Right? And you also have these other structures, which are going to be important too, and that is going to be your neural crest cells. And the neural crest cells are really important because they help in the development of what's called your ganglion cells, which are important within the digestive tract. For example, the myenteric plexus and the submucosal. Okay, and above this, what should you have? You should have the amniotic cavity right here. And then down here, what would you have connecting over here? You're still going to have the yolk sac. So let me bring the yolk sac down here. Okay, so we'll have the yolk sac down here. Okay. All right, so again, what are we going to have out of this then? We're going to have 3 guts that we need to remember. One right here is going to be the foregut. Right here is going to be the midgut. And right here is going to be the hindgut. Okay? Another important thing real quick is that this end right here towards the foregut is going to be help in forming the mouth. So you know what membrane we call that? We call this membrane right here because eventually it'll actually perforate and form a hole. This is going to be called the oropharyngeal membrane. So what happens is this will perforate around this end right here and form the mouth. All right? Towards this end, that's going to form the booty hole. All right, so towards this end, the hindgut, we're going to call this the cloacal membrane. And the cloacal membrane, it'll actually perforate and help to form the anus. It'll also help to form the urogenital tract as well. Okay? So now what happens, last thing here before we continue, is this is going to happen pretty much around the 4th week. Now, around the 6th week, what should happen is the midgut, right? The midgut actually has your intestinal loops around there, like the small intestine. So what's going to happen is the jejunum and ileum forms like a little loop. And that little loop around the 6th week actually kind of herniates out into the umbilical cord. Okay? So we can have the umbilical cord actually coming out here. Because you know, originally they called this duct right here. Around the 4th week, they called the vitellin duct. They call it the vitellin duct or the omphalomesenteric duct. I'm going somewhere. What happens is around the 4th week you form this. It's what basically connects the midgut to the umbilical vesicle, or we also call it the yolk sac. But what happens is around the 6th week, the vitellin duct should get obliterated. And then now this will no longer be there. So when this is gone then, what should we have? We should just have the umbilical cord. Okay, so at that point, when the vitellin duct is obliterated, all we should have left is just going to be the umbilical cord. Okay? So why am I mentioning this? Because, you know, if the vitellin duct doesn't actually obliterate, guess what you can have? You can have that mid loop get pushed or herniated out here to where it forms like a pocket out into this area, and what happens is the vitellin duct actually stays there and forms a ligament connection between the midgut and the anterior abdominal wall. Guess what they call that? Meckel's diverticulum. Okay? They call it Meckel's diverticulum. So the Meckel's diverticulum is going to be an issue whenever the vitellin duct does not obliterate and forms an outpouching of the actual small intestine. And it can be very, very serious if not treated, right? The other thing I wanted to mention is another part of the midgut, right? The intestinal loops. Remember I told you it actually naturally herniates. It naturally herniates around the 6th week. And the reason why is as the embryo is developing, the liver and some of the stomach and all those organs are really, really increasing in size and taking up the space within the actual midgut. So what do you think it's going to do? It's going to start pushing the intestines naturally out here into the actual umbilical cord. Naturally, that's okay. That's called a natural herniation. It usually happens around the 6th week. But what happens is, as the embryo starts developing and developing, the abdominal cavity should increase. As it increases, then it makes room for the actual intestinal loop to get sucked back into the abdominal cavity around the 10th or 11th week. But what is really important is that by the 10th and 11th week, it hasn't get pulled back into the abdominal cavity. Well, guess what you have? You have an omphalocele. Okay, so that's really important to understand. An omphalocele can develop whenever the intestinal loop does not come back in to the actual abdominal cavity. All right, so it'll have a peritoneal covering around it. And again, there is tests that you can do to determine if the actual fetus does have an omphalocele. You can do like an ultrasound, or they can do blood tests to test the maternal serum fetal alpha protein levels. All right, so whenever this embryo is folding, what are we going to get? We're going to get it in the foregut, the midgut, and the hindgut, but specifically, we're only going to see this folding, this craniocaudal folds, when we're looking at this embryo folding specifically in the sagittal plane. Okay, so this is going to be in the sagittal plane, okay? All right, so now we've already talked about the embryonic folding process in the sagittal plane. Now we got to talk about the embryonic folding process specifically in another plane called the transverse plane. All right, so the embryonic folding in the transverse plane. So now the only difference between this one is that what's going to happen is this area right here is going to start folding downwards and outwards. Okay, so this area right here where the amniotic cavity and the ectoderm is, it's going to start folding outwards and downwards. Now the endoderm is going to get sucked in. So this area is going to get sucked in and pushed out. Look what we get out of that. So let's go ahead and redraw that then. So look what we have here. We're going to have the ectoderm here. Right, so there's our ectoderm. And again, what should we have right here? We should have we'll have the notochord and also the neural tube. Then we'll have the paraxial mesoderm, the intermediate mesoderm, and this area right here, which is your lateral plate mesoderm. And again, paraxial, intermediate, lateral plate mesoderm, right? Now again, what did I tell you here what happened with the endoderm? The endoderm is going to start kind of like getting sucked in like this, and this part here is going to get pushed in and pulled outward. When that happens, we form that thing that we talked about before, which is called the vitellin duct, which is going to go to the yolk sac or the umbilical vesicle. Then, what else did we have up here? We had the amniotic cavity. Now, what's really cool here is that the amniotic cavity starts kind of folding down like this. Okay, starts kind of folding down like this. Now, let's put our linings back on there again. What do we have here? Before, we're going to have this as the splanchnic mesoderm. So the splanchnic mesoderm is going to come right here, right around the vitellin duct, the endoderm, and the yolk sac. Right? Sweet deal. Show it going right here. Okay? Then what else are we going to have here? We're going to have the somatic mesoderm. The somatic mesoderm is going to come out here, and it's going to line this outer part here, right? The amniotic cavity. All right, and then outside of that, we would have the chorionic cavity, but we're not going to show that. That's too much drawing. All right, so now, after that, it's going to come inwards, and we got this now. All right, here's what's really cool. As this continues, as these lateral folds keep pushing down and coming closer and closer and closer, this area is going to fuse. So it's going to fuse. Remember I told you the vitellin duct should obliterate. And then eventually what will happen is you'll have the umbilical cord which will connect between the actual fetus and the mother, right? But again, what should happen is the vitellin duct should obliterate and these folds will merge together. You know what happens if the lateral folds don't merge together? Guess what? The small bowel can herniate out through that lateral fold. You know what that's called? Gastroschisis. So that's the difference between omphalocele and gastroschisis. What happens is the actual specifically parts of the gut herniate out through this point here where the lateral folds don't completely close. That's called gastroschisis. And what happens is the intestines don't have any peritoneal covering. Guess what? They're completely exposed in the amniotic cavity, which can agitate the intestines. And that can be very bad, all right? So again, let's show this part here where the lateral folds fuse, because this is really cool. This is where it gets good. All right, now, we're going to bring this bad boy down and we're going to show the complete fusion process here, because this is going to lead us into our next topic here. So again, now what will we have here if we draw everything the same way? Right here, there's our gut tube. What should be surrounding the gut tube? What do we call this? This is the splanchnic mesoderm. The reason why I'm telling you this is because guess what the splanchnic mesoderm forms? It helps to form the walls of the GI tract. For example, the submucosa, the muscularis externa, the lamina propria, all those different parts, and the visceral serosa, or the visceral peritoneum, which is extremely important. Now, around the walls here, what should we have? Around the walls, we should have the somatic mesoderm. So this should be the somatic mesoderm right here. Now, the somatic mesoderm is important. Why? Because it helps to form the parietal serosa, or the parietal peritoneum, which is extremely important. What happens though is we have to develop a connection between the parietal serosa, or the parietal peritoneum, and the visceral serosa, or the visceral peritoneum. What do you think that connection is right there that keeps that organ suspended within this peritoneal cavity? What do you think that's called? It's called a mesentery. Okay, so this right here is called a mesentery. And these are extremely important. What is this here called again? This is called the parietal serosa, or parietal peritoneum. And this one right here is going to be called the visceral serosa, or visceral peritoneum. Okay? And this is going to be the peritoneal cavity. The reason why I'm mentioning this is because any organ that has a mesentery and has this visceral serosa and this parietal serosa, and then to have the two connecting together through a mesentery, are primarily going to be intraperitoneal organs. So let's write that down here. If this guy has a mesentery, it's going to help us to determine that this should be a intraperitoneal organ. Okay, this is extremely, extremely important. Okay, so if it has a mesentery and it has a visceral serosa and a parietal serosa, it will be an intraperitoneal organ, meaning it's inside of the peritoneal cavity, suspended within it by a mesentery. If it doesn't have a mesentery, or if it did have a mesentery previously, but it loses it as it's getting developed and pushed and obliterated against the posterior abdominal wall, they can be called retroperitoneal organs. So let's say, here's the peritoneum, right? If it has to be retro, it has to be outside of it or behind it. So what are we going to have back here? I'll draw a couple of examples here. Let's say back here I could have the kidneys. So I could have the kidneys right here. What else could be around this area? What's on top of the kidneys? I could have the adrenal glands, right? What else could I have back here? I could even have the parts of the duodenum, right? So I could have parts of the duodenum right here that we'll talk about. And we'll get into all this, but I just want you guys to understand here that if there are organs located outside of the peritoneal cavity, not suspended by a mesentery, these are called retroperitoneal organs. And we'll talk about these. Okay, so what do? We talked about intraperitoneal and we talked about retroperitoneal. But now we got to have a little bit more of a discussion. We have to talk about the differences between primary and secondary. For example, the big vessel in the abdominal cavity, we call it the abdominal aorta. That's one. So the abdominal aorta, that's a big one. The vein that's right next to it, which is called the inferior vena cava. What else? Okay, well, what else is up in the top part of the actual abdominal cavity? Another one is going to be the adrenal glands. So the adrenal glands. What's below that? The kidneys. Okay. What else? You know, what's the tube that takes urine from the kidneys down to the bladder? The ureter. So we're also going to have the ureters. And then what's the structure that collects it? The bladder. All right. And then one more part here is around the doodle hole, right? Around the doodle hole, you're going to have the rectum, but specifically the lower rectum. Okay? The lower rectum. Okay, so primary retroperitoneal organs never had a mesentery, right? So if they don't have a mesentery, they're not going to be found inside of the peritoneal cavity. They're going to find posterior to it. Now, these are the abdominal aorta, inferior vena cava, adrenal glands, kidneys, ureters, bladder, lower rectum. All right, so the secondary. For the secondary retroperitoneal organs, they did have a mesentery at some point in time. So when they have that mesentery, right, during the rotation of the gut, as it rotates around the central axis, some of these mesenteries get obliterated against the posterior abdominal wall. And then when they get obliterated, they lose their mesentery and then they develop outside of the peritoneum, posterior to it. Those organs are secondary retroperitoneal organs. For example, one is going to be the second, third, and fourth parts of the duodenum. Okay, if you keep going, we'll get to the ascending colon, like I told you guys before. The ascending colon. And then also the descending colon. Now, if we talk about some accessory structures around that, right around the duodenum, you have the head and the body of the pancreas. So we also have the head and the body of the pancreas. All righty. So these are going to be secondary retroperitoneal organs, but there's also going to be some other structures that we can include in there, but I'm just trying to get the main ones here, okay? So the main ones that we're going to be talking about with respect to these primary and secondary is, for primary you can have the abdominal aorta, inferior vena cava, adrenal glands, kidneys, ureters, bladder, and the lower rectum. And even one more, technically we can have the esophagus. Okay? Okay. Now, last thing I want to say before we move on is, if they don't have a visceral serosa, right, and they don't have a parietal serosa, then what do they have to anchor them to the posterior abdominal wall? Well, in order for them to be anchored to the posterior abdominal wall, retroperitoneal organs have to have a specific thing, a specific connective tissue that anchors them to the posterior abdominal wall. This is called adventitia. Okay? Adventitia is actually going to be like a dense fibrous. So what is it called? It's called a dense fibrous, specifically irregular connective tissue. Okay? And what it does is it anchors these organs to the posterior abdominal wall because they do not have a visceral serosa or a parietal serosa, and they don't have a mesentery to keep them suspended there. So they have to be anchored. So there's not very much mobility there. However, Things that do have a mesentery, do have a visceral serosa and a parietal serosa, and keeps them intraperitoneal, they have a little bit more mobility, okay? All right, guys, so we talked about a lot of stuff within this video. We talked about the embryonic folding process, we talked about the intraperitoneal organs, retroperitoneal, and the pathologies associated with it, right? In the next video, what we're gonna do is we're gonna talk about the foregut, the midgut, and the hindgut, their components, their vascular supply, and their mesenteries, okay? All right, engineers, so I thank you guys for watching this video. I really appreciate it. If you guys did like this video, please hit the like button, comment down in the comment section, please subscribe. Also, guys, we have an Instagram. We also have a Facebook account down in the description box. Please go check that out. And also, we have a Patreon account developed. Every dollar helps us, guys. Please, it helps us to be able to get good equipment, make these videos as high quality and as beautiful as possible for you guys. All right, Ninja Nerds, until next time.